Hey guys, welcome back to another video. Today we'll be talking about serotonin. Serotonin, also known as 5-hydroxytryptamine, 5-HT, is a neurotransmitter that plays a crucial role in regulating the wide range of physiological processes, including mood, appetite, and sleep. In this video, we will explore the neuroscience of serotonin synthesis and its functions in the brain. Serotonin is synthesized in the raphe nuclei of the brainstem in a series of two enzymatic reactions that convert the amino acid tryptophan into serotonin. This process involves turning tryptophan into 5-hydroxy-L-tryptophan, 5-HTP, with the enzyme known as tryptophan hydroxylase, TPH, which is the rate-limiting enzyme in the synthesis of serotonin. Next, 5-HTP is synthesized into serotonin through the enzyme aromatic amino acid decarboxylase. Recent research has identified several regulators of TPH, including GPR56 and P11, which can modulate the activity of TPH and promote serotonin synthesis in response to different stimuli. There are many serotonin receptors in the brain, many with complex functions still vaguely known to us, but the ones we will discuss are 5-HT1A, 5-HT2A, and 5-HT3. These receptors are widely distributed in many areas of the brain and are involved in a range of physiological processes, including mood regulation, perception and cognition, and appetite regulation. It has identified specific subtypes of serotonin receptors and their functions. For example, the 5-HT1A receptor is involved in the regulation of mood and anxiety, while the 5-HT2A receptor is involved in the regulation of perception and cognition. Serotonin is perhaps best known for its role in mood regulation. Low levels of serotonin have been associated with depression and anxiety, while increased levels have been linked to feelings of well-being and happiness. This is mainly pop science, as saying neurotransmitters only have one role is undershadowing their real importance. Serotonin is most known by the general public as the feel-good chemical, but many of its effects are very unknown. Research has identified specific brain regions and circuits involved in serotonin-mediated mood regulation. For example, serotonin signaling in the prefrontal cortex is involved in the regulation of mood and anxiety, while serotonin signaling in the amygdala is involved in the regulation of fear and anxiety. Serotonin is also involved in the regulation of appetite. It is believed that serotonin helps to regulate the food intake by influencing satiety and hunger signals. Low levels of serotonin have been linked to increased appetite and overeating. Research has identified specific brain regions and circuits involved in serotonin-mediated appetite regulation. For example, serotonin signaling in the hypothalamus is involved in the regulation of appetite and energy balance, while serotonin signaling in the nucleus accumbens is involved in the regulation of reward-related feeding behavior. Serotonin is also involved in the regulation of sleep. It is believed that serotonin can help regulate the sleep-wake cycle by promoting wakefulness during the day and initiating sleep at night. Low levels of serotonin have been linked to sleep disorders such as insomnia. Research has identified specific brain regions and circuits involved in serotonin-mediated sleep regulation. For example, serotonin signaling in the dorsal raphe nucleus is involved in the initiation and maintenance of sleep, while serotonin signaling in the suprachiasmatic nucleus is involved in the regulation of the circadian rhythm of sleep. In conclusion, serotonin is a neurotransmitter that is involved in a wide range of physiological processes in the brain. Its synthesis and regulation are complex, involving multiple enzymes and regulators. Serotonin receptors are widely distributed in the brain and are involved in regulating mood, appetite, sleep, and other important factors. Research has identified specific brain regions and circuits that are involved in the serotonin-mediated regulation of these processes. While serotonin is often associated with mood regulation, it's important to note that its functions are complex and multi-faced. By exploring the neuroscience of serotonin synthesis and its functions in the brain, we can gain a better understanding of how this important neurotransmitter affects our daily lives and overall well-being. Thanks for watching, guys. This is a bit more of a complex video. I didn't want to dive too deeply into it. I want to remain more on the pop science side, because around 90% of serotonin is actually produced in the intestines, and that's not much of the pop science. Nobody really knows what the intestine stuff does because that doesn't regulate mood. So I kept this more on the pop science, but it went into a bit of detail about the actual synthesis side. So thanks for watching, and we'll see you in the next video.